All right. So we now know, oops, I mean, just funny technical issues today, but we'll just get through it. We now know how to count things in moles. Just like we say 1 of, or 12 of something is a dozen, we say 6.02 of something times 10 to the 23rd is a mole of something. But how many moles are in a mole? You're like, well, how many moles can be in a mole? Isn't 1 mole in 1 mole? Well, if we think about it, that's not always the case. Let's think about some examples. If I have got a dozen cars, right? You're like, well, okay, that's 12 cars. How many wheels do I have? Well, if each car has 4 wheels, I've got 12 times 4. That's 48 wheels. What's another way of saying 48? It's 4 dozen. So in 1 dozen cars, I have 4 dozen wheels. And we're going to find that anything we can do for a dozen, we can also do for a mole. So I'm going to give you a preview of what's coming in just a minute. If we have 1 mole of cars, guess what we have? We have 4 moles of wheels. Now, we're not going to use cars and wheels. Today, we're going to use M&Ms as our example. And we're going to pretend we're in the perfect world where every single packet of M&Ms is exactly the same. For those of you who are a little more OCD, wouldn't that be a great world? So every single packet is exactly the same. And we're just going to say that every packet contains 3 blues, 7 yellows, 2 oranges, 4 reds, 2 browns, and 2 greens. So if I have 2 packets, right, I just multiply each of those numbers by 2. I get 3 times... I can even do this in the right color. I get 3 times 2 equals 6 blue. I don't really have yellow, so let's skip to red. I get 4 times 2 is 8 red, right? And we could do that for any of the colors. What if I had 10 packets? If I had 10 packets of M&Ms, I would have what? 3 times 10 equals 30 blue, and 4 times 10 equals 40 red. Right? And you could just kind of go on like that and pick any number you want and just multiply it out. But let's switch. Instead of talking about packets, let's talk about a dozen packets. What if I had 1 dozen packets of M&Ms? And we're just going to focus on blue and red for now, even though I didn't write that last red one in red. We're going to focus on blue and red. So if I have a dozen packets, what do I have? Well, each packet contains 3 blues. And then a dozen is 12, and so I've got 36 blue. And each packet contains 4 red, and a dozen is 12, so I've got 4 times 12 is 48 red ones. And most people would be able to come up with that on their own without too much of a difficulty. But what's another word for 36? Well, another word for 36 is 3 dozen. And what's another word for 48 is 4 dozen red. Well, that's interesting. When I had 3 dozen blue packets, I ended up with, when I had 1 dozen packets and there was 3 blues per packet, I ended up with 3 dozen blues. When I had 1 dozen packets and there were 4 reds per packet, I ended up with 4 dozen reds. There's a correlation here between how many are in each packet and how many dozen we get. Does that extend out? Right? What about if I had 1 mole of packets? Now, 1 mole of packets of M&Ms would be a crazy amount of M&Ms. It would probably fill up about half of the volume of the Earth. So we're not actually going to do that. But let's say I was talking about that. 1 mole of packets. What would I have there? Well, if I had 1 mole of packets, then that's hard to think of, right? Because moles are a little bit harder to think of than dozen are. You're like, okay, I can picture dozens. I can actually see them in my head. None of you can picture a mole in your head. It's just not possible. Our brains aren't made for that kind of scale, which is why we developed the word mole so that we can think of 1s and 2s and 3s. So how do we imagine that? Well, 1 mole is 6.02 times 10 to the 23rd packets, right? And we know that there's 3 blues for every 1 packet. And so we can multiply that out, and I'm just going to round it. We get 18 times 10 to the 23rd. 18 times 10 to the 23rd packets. I'm going to move this guy down here. We don't need him yet. So, whoa, I don't know what just happened. Huh, I now have 2 copies of it. I don't know, I need to put 2 copies of it. Okay, sorry about the technical difficulties. I'm sometimes tempted to re-tape these things, but I make mistakes too. I want you guys to see that funny things happen even when we're working on these things. All right, so my packets cross off. I end up with blues. I have 18 times 10 to the 23rd, or 1.8 times 10 to the 24th blues. So I've got a lot of blues. And again, those are really hard numbers to count. But guess what? If I wanted to know my 1.8 times 10 to the 24th blues, and I wanted to know how many moles of blue that was, what would I do? I'd put blue down here. I'd put mole of blue up here. Right? We want the blues to cancel. And then what was my relationship between moles and blues? I've got 1 mole is 6.02 times 10 to the 23rd blues. If you do that math, you get with 3 moles of blues. So 1 mole of packet, each packet contains 3 blues. 1 mole of packets, each packet contains 3 blue, then we have 3 moles of blue. You can do that math over and over again. You'll always find that. Okay? And what we want to do is we want to try to skip that math if we can. We don't want to have to go to numbers of blues and then back to moles of blues and stuff. Can we always just do that ratio? And the answer is yes. If we look inside something and we've got a dozen of them, and inside that dozen, each of those things has 4 things like our cars and our wheels, we can always say that 1 dozen cars is going to be 4 dozen wheels. We can always say that. We can say that 1 mole of packets contains 3 moles of blues. And it's going to be a very useful way of doing some what we call stoichiometry later on in this chapter. So let's generalize that a little bit more. Let's do an example where we're going to talk about the reds now. Now let's say I had 1 mole of packet. And if you remember, there's 4 reds per packet. How many reds would I have? Hopefully you came up with 4 moles of reds. So what I'm going to do is I'm just going to start with 1 mole of packets. And what I want to know is moles of red. That's actually what I'm asking. I'm starting with moles of packets and I want to know moles of red. So how do I do that? Well, get your units right first, get your numbers later. Moles of packet go down here. Right, because 1 on top, 1 on bottom cancels, and moles of red go up here. And now you might stop and be like, well, gosh, I don't know what the relationship between moles of red and moles of packets are, because I don't really understand this concept of a mole yet, so how am I supposed to know what the ratio is of these moles? Take a deep breath. Anything you can do with moles, you can do with a dozen. Anything you can do with a dozen, you can do with 1. What do I mean by that? I mean that if we have these conversion factors and we're looking for moles of red over moles of packet, or we can think of it in a different way, which is dozens of red for dozens of packets, and in fact we can even think of it just like this. How many red per packet? Right? Why does that work? It works because if you've got 1 of something, right, and let's go back to our cars. We have one car, it's got 4 wheels. If we have 12 cars, it's not like my ratio of wheels to cars all of a sudden changes. So in my 1 dozen cars, I have 4 dozen wheels. And then since a mole is just another count, it's just a count just like a dozen, just an unfathomable count, then my ratio of 4 wheels to 1 car doesn't change. And so here, my ratio was 4 reds to 1 packet, which means I have 4 dozen reds to 1 dozen packets, which means I've got 4 moles of red to 1 mole of packet. And I can put that up here, 4 to 1, and I find that I get 4 moles of red. So maybe it's just starting to sink in just a tiny bit, but where does this get us usefulness? It gets us usefulness when we have stranger numbers, when we want to know. Again, I'm going to move this guy down because I don't want him here yet. Okay, let's say we wanted to know how many blue M&Ms in 17 point, let's do 12.24 moles of packets. Right? And actually, how many moles of blue M&Ms? How many moles of blue M&Ms in 12.24 moles of packets? Even if you got that ratio down, you're like, oh, the 3 to 1, 2 to 1, it might be a little bit harder to think about it when you're talking about 12.24. But again, that 12.24 is just something you put in the calculator. We're going to set everything up just the same. We're going to start with our 12.24 moles of packets. And we're going to try over here to get moles of blue. What goes on the bottom? Right, we're trying to get rid of moles of packets, so it's got to go on the bottom. 1 on top, 1 on the bottom cancels out. I'm trying to get moles of blue, so it's got to go on top. And what's my ratio? Moles of blue to moles of packets, hard to think about. So don't think about that. Think about how many blues are there per packet. Oh, I just look back up here. There's 3 blues per packet. And we put that in there. There's 3 blues for every 1 packet. And we just multiply this number by 3. And we get 36. And what is 24 times 3? 24 times 3 is 72. 36.72 moles of blue. What do we do about sig figs? These numbers here are exact. We don't worry about their sig figs. We counted. There's 3 blues for every packet. So that's a counted number, an exact number. We don't worry about sig figs. So I had 4 sig figs to begin with here. I ended up with 4 sig figs at the end. All right. We're going to keep doing this in a lot of different contexts, but that's the introduction to how we do math when there's packets of things inside our packets, 3 blues in our packet. And the packets we're going to be dealing with are packets of molecules. Okay? So here's a question. How many moles, I'm going to delete this guy here. No, it's not going to let me delete it. That's really strange. Sorry about that, folks. All right. So how many moles of fluorine atoms are in 2.5 moles of calcium fluoride? Well, first we got to figure out what is calcium fluoride. Now this is going back to the last chapter where we learned how to make ionic molecules. We've got calcium and we've got fluorine. And it's very tempting to say calcium fluoride is CaF. But remember, what we always have to do for ionic molecules is we always have to look at the charges. So you go back to your periodic table over there, you figure out calcium is in the second group. It's an alkaline earth metal. And all of those have a charge of +2 because they've got 2 valence electrons. You find fluorine over there in the halogens on the right, 7 valence electrons. Its easiest way to 8 is to add 1. And so now we've got Ca2+ and F-. How do we balance that out? We need another minus, and we get CaF2. So 2.5 moles of calcium fluoride. And what are we looking for? We're looking at moles of fluorine atoms. That's what we're looking for. And so we put that into a conversion factor. What goes on the top? Right, on the top goes moles of fluorine. Moles of fluorine. On the bottom, moles of calcium fluoride, because one on top, one on the bottom is how we cancel things. Now, how many moles of fluorine are in 1 mole of calcium fluoride? I don't know. I can't count in moles. But it's the same concept as how many fluorines are in a calcium fluoride. And you're like, well, the formula there says 2. Right? So there's 2 fluorines for every 1 calcium fluoride. Numbers stay attached to their units. There are 2 fluorines for every 1 calcium fluoride. You multiply that out and you get 5.0. Again, these are exact here. So I had 2 sig figs in my starting number. I have an exact conversion. And I find that there's 5 moles of fluorine atoms in 2.5 moles of calcium fluoride. So we're going to see this over and over again in our calculations, especially as we get to the end of this chapter. And we're going to keep up with that probably throughout the class, using these ratios that inside molecules, these formulas tell us ratios, that for every one of these things, there's 2 fluorines for every calcium. I'm sorry, 2 fluorines, 2 fluorines for every calcium. And so we can always use those ratios to help us figure things out. And we'll figure out later on why it's useful to do that. Right now, you probably have absolutely no idea why it's useful for me to calculate that I need 5 moles of fluorine atoms. And I get that. We'll get there. Right now, we're just going to go through the mechanics of why would we want to do that. All right, hope this was helpful. We'll see you next time.